Hello everyone, and in this video I'm going to show you how to use the plane stress element to analyze a plate with a hole as shown on this tutorial document. So you should be able to view this document on the module 9 and for the tutorial 3. And so there is a document there. So this plate has a hole in the center, and this plate is under pure tension on both ends. So we should be able to use the plane stress element to analyze it, because um, if you apply the uniformly distributed load on both ends, the stresses will not be uniform close to the around the hole in the center over there. So now let's see how we can create the model and the mesh and the geometry with plane stress elements and do the analysis here. So this plate has a 4-inch by 4-inch geometry, and the thickness is 0.1 inches, and the diameter of the hole is 1 inch. So we are given the material properties here. As you can see here, because of the symmetry of the geometry as well as the loading over here, we can use only a quarter of the whole geometry to do the analysis here. So we only need to model 1/4 on the top right corner of this there. So firstly, let's open the Abaqus. We change the work directory. I have already created a work directory on my uh, OneDrive. So change it, work directory. And we have tutorial 3. This is our work directory. So we have everything here. Next step, by following the tutorial here, we create the sketch and create the geometry so that we can have the uh, sketch over there. So we go to sketch and create the more geometry, the approximate size, it doesn't matter. Here we use that 5. So we have the 4-inch by 2-inch. So we create the model, and either we input the coordinates. We can follow the tutorial. We create the points directly, and then we auto fade to do the collect lines to create the model, or we can just go ahead using some AutoCAD some CAD techniques over here. For example, we can just go ahead to create a corner. We have 2-inch by 1-inch. What is the first one? And let's redo that. First one, 0, 0. So it's 4-inch high and 2-inch wide. So we use 1/4 as a 2-inch high and 1-inch wide. Right? So we enter it says 1-inch, 2-inch. This is and there is a hole. The hole size is 1 inch. I believe that's a 1-inch diameter. And so we create a hole here. We create a hole. That's we just create an arc through 3 points or through center and 2 endpoints. Right? So create the center here. And so the hole size, that's half. So the radius is 0.5 inches. That's 0.5 and the 0.5. That's a hole. That's. Then we trim, and we do the trim here, the trim here, and here. We got the geometry. This is the geometry. So we click the cancel procedure, and now we are done. We're done. So the sketch has already been created. This is the sketch one. Then we go back to part, and we create a part. Part one, that's two. That's a 2D, and then it's the formable. That's shear. We have the proxy size. We have 5. So we can import from the sketch. Add a sketch here. This is a sketch we have already created, right? So do you want to reposition? We can just down and the matter here. The down and the click down. Everything is down. So the geometry is down. And remember to save the model. So we have already created the geometry. Next step, we define the materials. It's been a while since last time we used the Abaqus. We created that property, the material. So we have the material modules of elasticity, 10 times 6. Please keep in mind to be consistent with the units you use here. We use the pounds for forces and the inches for distances. So here that's mechanical elastic. So tens x Poisson's ratio, that's 0.3. So we have everything here, and then we have already defined the material. Then we define a section, so that should be a solid, homogeneous, or plane stress, and it's a simplified approach for solid analysis. So it's like solid, homogeneous. We continue. That's material one we just defined a few minutes ago. Stress and strain thickness. The thickness is 0.1 inch. 1 inch. 0.1 inch. Click OK, and then now we have the section defined with the material one attached to it. Then we assign the material and we select the region and then click OK, done. So the section one is assigned or is attached to the material here. Assignment. We're done here and save it. This is the property. Next tab, we go to assembly, create assembly, dependent or independent, doesn't matter because we have only one part. Just probably independent would be easier for us to do some modifications later. Anyway, just click OK. Assembly is done. Step, we go to step, create a step 1 after initial. So it's static general. No changes from the default settings here. Then we go to interaction. No interaction here. Just apply the load. So there will be when we talk about the load includes the pressure applied to top and the boundary conditions on the edges there. So now let's apply the pressure firstly. So it's a pressure. We have the pressure node 100 psi. Continue. Select the top. It's 100 psi. Oh, so this tension, right? So probably will be better to change the value. It's a negative. So now it's It's tension, no, it's tension. It's in tension, not in compression. So this is a load. This is this is a load. Next step, we can apply the boundary conditions. So for the vertical, the left vertical, and the bottom horizontal, we need to apply boundary conditions. So there are two ways. One way you can use the way that the tutorials gives you. The other way we can just use symmetry. Symmetry. Just use symmetry. For example, this. There will be symmetry. So everything is but this is a y symmetric, x symmetric. Sorry, so everything. So the u1 should be equal to 0. And there will be no movement in the horizontal direction. So this is the u1 symmetry and then the y symmetry. Y symmetry. Everything is the geometry is already defined. So this is the load. Next step, we go to mesh. Mesh. So mesh. When we do mesh, there are two ways to do the mesh. We have the um, element size. We use 0.1 inches, and there are some um, controlling about the sizes here. Right? Sizes here. So we go. Firstly, we go mesh. We do the shade the edges. And then select the regions to be assigned with no cause shades. So we assign all of the edges. The size is 0.1. So firstly, we try no bias. So there is no curvature control here. So that's the edges here. So the length of each element is 0.1 inches along the edges here. Then we just assign element type. So we use firstly we try the linear, try angular shape. So it's a 3-node linear plane stress triangle. So the tutorial requires us to use linear triangle. Okay, is the 3-node linear triangle study. So we have already signed that. Then we need to control the region. So whether we need the quad shape only or or we use triangular shape only firstly. So then we do the mesh. So we have already meshed it. As you can see here, there is no quad shapes, quad lateral shapes. All of the elements are triangular shapes. We save it, and let's compare the shape and that's in linear interpolation. That's a 3-node triangle. So everything is triangle. Let's say what would be the results look like. So now we submit a job, right? Create a job. This job would be linear. So that's triangular shape, linear interpolation, and low bias. No bias. So no changes over here. So You can see here, we have already created job. Typically, for this tutorial, it's better to use some unique names for different types of meshes, so that we can have different files there to compare with each other. So we can submit results. So the results will be stored in the work directory that we created at the beginning of this tutorial. It's running. It's completed, and so we can see the results. We click the results. So this is the results. So the results has already been loaded over here. The same name of the job name. So we can check the stresses actually. And this is the misset stress, and there are different stresses here. So S11, S22, and S33. Or S11, that's the stress in the X direction. Let's see the stress in the Y direction. So the results is averaged. So if we would like to show the unaveraged results, we can go to the results option to uncheck the average ones. So those are the results. So as you can see here, the maximum occurs. So as you remember, the load is 100 psi on the top, but the maximum y stress in the y direction is about 3.95. So it's almost 4 times the load here. So this is the case where we use the trilinear and the low bias results. I think this is the first try. So we can also change the mesh types. We go back to mesh, and then we delete all the meshes. So we use a different material, different linear. We use the quadratic interpolation. And that's a sixth of quadratic interpolation here. So different. So similarly, we use the LST, right? LST. So we do the mesh again. And the same, almost the same shape, right? For the meshes there. And then we go back to the job, okay, create another job. So that's, we can just make a copy. But there are only changes will be, this is the quadratic. The quadratic interpolation here. So we submit this result. Yeah, so this is the, let's say what would be the difference here. As you can see here, linear and the quadratic, both of them in the process, but they are different results. We show this number, show the S1, S22. So in the fourth, the stress is another, but 4.415. That's very similar to the results we have here. So this is the case we have the quadratic interpolation. We can try the full load quad shapes too. We go back to the mesh. We net meshes. We use a different material. We use a different elements. We try the linear firstly. And then we control the mesh size. We use quad only. and then mesh. This is a for called natural shapes here. So then when I go to the job, we so that's a linear. We copy the plot one, and click OK. So another one is created, so we submit it. Okay, so this is done. We go to the results. This result is shown here too. So let's check the S22. So similarly, at Abaqus here, but the maximum stress is the smaller here. Or we can use the quadratic interpolation for this case too. We go to the mesh. We go to delete all of them and change the element type. So instead of using linear interpolation, we use a quadratic interpolation. So that's 8 load. And then we do the mesh. Then we do the analysis. Go back to the job. We make a copy. The only difference is that instead of using linear interpolation, we use the quadratic. Then we do the analysis. Submit it. As you can see here, with Abaqus, you can use different element types for the same geometry, and you can do some parametric analysis here. It's done. We go to the results. It's quad bias, bias. Let's see the results here. It's 2, very similar, to. It's 4.3, some higher. So similarly, we can also go to the mesh to change the geometry here a little bit. First thing, let's go back to the triangular. To that, and we instead of non-bias, we use single bias. Let's say later we need to use a single bias, or we use a single bias, and we can use the minimum and the maximum is 1, so that we can refine the mesh somewhere. So just select the bottom edge and arc. We can use some bias there. So that means that we can select the arch from the bottom. We can change that size locally here. So we use single bias. The minimum size is 0.02. The maximum is 1.0. I use another. So then we use the triangular shape. And then we do the mesh. Select the triangular shape, and then we do the mesh. Oops, something wrong here. Maybe the maximum should be 0.1, I believe, here, because it's mesh locally. Let's redo that. So the maximum size is 0.1. We don't go too much here. There is a typo in the tutorial document. I think this makes more sense. This makes more sense. And then we'll go to the job, create a triangular with single bias, linear with bias, bias. So we submit the result. So it's done. We can check the results. As you can see here, that the results is also a function of the mesh configurations. As you can see here, if we have refined the mesh sizes for those regions, we will have larger stresses there, 4.7, 4. Oh, that's the S11. We just look at S22, and that's 4.243. 4.243. Let's compare what we had before for linear interpolation. 4.4. It's 4.2, and maybe 2. Linear interpolation. Anyway, yeah, it's there are some difference. It's about 5% difference, but I think that's within the expectation over here. So, and for the remaining part, there are more part over here, so you can also check the results there. So, for example, you can also check the S11, the stress in the x direction. So it's a two-dimensional analysis even, and that node is only in the vertical direction. There are some stresses in the horizontal direction, but smaller. And let's say S33, that's in the z direction. There is no stress, right? And S12, that's the shear stresses. The shear stress. You can also show the maximum shear stresses, right? But then shear stresses in we can also show the maximum value and the minimum value. And the maximum and minimum values can be shown. So I will have you to do the remaining of this job, and I will give you some assignment to see whether you can get the results over here. I think that's all for this video, and good luck to your practice. And I think that's all. Thank you.